Hey, welcome back to Mr. Phelps with Precal. This is Unit 1, Topic 1, Lesson number 11. And in this one, we are talking about whether or not functions are odd or even functions based upon their inverses. Number 1, so we're given two functions, f of x and g of x, and we're asked to find f of g of x and g of f of x, which is composite functions. So in this case, we're going to take f of g of x, we're going to take this, plug it in for this x, so it's going to be square root of, and this is going to be x squared plus 7 and then minus 7. And then we can... Okay, and then technically these parentheses are no longer needed, and the plus 7 and the minus 7 are going to cancel each other out. And then you're left with the square root of x squared, and you know that those are also inverses of each other, so you're left with just x. If I do the same thing going the opposite direction, I'm going to take this and plug it in for x, so it's this x minus 7 being squared and then added to 7. Well, first things first, once again, squared and square roots are inverse of each other, so you're left with just x minus 7 and then added to the 7, which these cancel out, and you're left with x as well. So you are left with the same thing, but which makes you think that these two are inverses of each other. But in this case, they are technically not inverses of each other, because as we know before, square roots have restrictions on their domain, and square roots do not. So I'm sorry, squares do not. So this squared is fine, but when you do the inverse of it and you turn it like this, you have to restrict the domain to just one side. So we kind of know before I even did this problem that these were not going to be inverses of each other. And the reason why is because they don't have the exact same domain. So the domain of the first one, so we have square root. So this one is just... This is just the domain of all real numbers. And in this one, you have limitations because in this case, when you have this square root of x minus 7, see, you can make this anything you want, and you're just going to get the absolute value of x. Forgot about that because technically x could have been a negative. So this one actually works out because x can be a positive, x could also be a negative. But in this one, you can't just say x can be a positive or a negative because if x... if x is like, if x is like 1 and 1 minus 7 gives you a negative, there's no such thing as a square root of a negative. So you can't just wipe out the square root in the squares because that wouldn't make any sense because then you have imaginary numbers inside here. So this one technically tells you that x minus 7 has to be greater than or equal to 7. And the reason why is because, well, say it can equal 0. I'm sorry, let me take this back for a second. So x minus 7 cannot equal 0 because then it cannot be less than or equal to 0. Has to be greater than or equal to 0. So because if I add 7 to both sides, x has to be greater than or equal to 7. Because like I said before, if you have a number that's less than 7 right here, then you're going to get a negative number on the inside, and therefore it's not going to work out. So technically this means that the domain here is restricted to 7 to positive infinity. It can be anything that's greater than that. So therefore these two don't have the same domain, so therefore they are not technically inverses of each other. Whereas this one I believe is actually going to work out. So g of x, so if I take all this and plug it in right here, so that's the cubic root of x minus 5, and I do all of that cubed and I add 5 to it. So first of all, cubes don't have the same restrictions as square roots because cubes a negative times a negative times a negative is still a negative, so it actually doesn't matter. So these two do actually cancel each other out. So you're left with just x minus 5 plus 5, but then the minus 5s and plus 5s cancel out, and you're left with just x. If I do it the other way around and I take all this and plug it in right here, so then I've got, f of x into the g of x, or did I just do them backwards? No, I didn't. Okay, so if I take all of this f of x and plug it in for this x right here, so I get the cube root of x cubed plus 5, and then take away 5 after that. Okay, so these parentheses are no longer needed, so these basically cancel each other out, and then cubic root and cubed cancel each other out, and you're left with just x. And then, like I said before, there's no restrictions on either of these, so the domains are going to be all real numbers, because cubic roots actually can be all real numbers, because cubic roots go like this, whereas squared roots go like this, and they restrict the other side. Okay, so when you input in a negative x, you'll get f of negative x equals f of x. Okay, so when you input in negative x, what will you get? So when you look at this, the height of xy has the same height of negative x. So what you're going to notice is the input of negative x, you're going to get the exact same output. So in this case, that's what proves this true. So if f of x equals x squared and you decide to put 2 in for x, well, 2 squared is 4. And if you choose to do f of negative 2, you'll also get 4. Negative 2 squared is also 4. It's going to be the exact same answer. Either way, so that's the way it works for even functions. For odd functions, when you input to negative x, you are going to get the opposite answer. So you're going to get xy. So when you input negative x, you're going to get the exact same answer up here. Let me move myself. So if you put x squared, say you put in 2 for x, 2 times 2 times 2 is 8, and then you do f of negative 2, you're going to end up getting negative 8. So you're going to get the opposite answer. So instead of getting 8, you're getting negative 8. Opposite answer, which is the reason why it's negative f of x, which is the reason why we can tell if these are even functions or odd functions based upon what you get when you do the f of negative x. Sorry. When you put in negative f of negative x, say it correctly, so which means that this is negative x squared minus 4. Well, negative x squared is really just x squared, because a negative times a negative is a positive, and minus 4, and you end up getting the exact same thing you had to begin with, which makes this an even function. If we do f of negative x for this one, so we have 5 times negative x. We know this x is negative x now because of this. 5 times negative x is negative 5x, and this is the exact inverse of this, which means this is an odd function. F of negative x for this one equals negative x to the 5th minus 4 times negative x to the 3rd. Okay, so a negative times a negative times a negative 5 times is still going to be a negative. So that's negative x to the 5th. So this is still going to be a negative, negative x to the 3rd. So a negative times a negative times a negative is still a negative. So that's still negative x to the 3rd. And a negative times this negative here makes positive 4x to the 3rd. And if you look closely, this is the opposite of this. This is also the opposite of this. This is an odd function as well. For this one, so f of negative x equals negative x to the 4th plus 2 times negative x to the 2nd. Okay, so as we talked about before, so negative times itself 4 times. Negative makes it to a positive, makes it back to a negative, makes it back to a positive again. So this is really just x to the 4th. And this is, okay, so this is also going to be a positive x squared, so plus 2x squared. And you're getting the exact same thing, so this is an even function. For this one, negative x to the 3rd plus negative x squared plus negative x. Okay, so this is going to be negative x to the 3rd. This is going to be plus x squared, and this is going to be minus x. That's the exact opposite. So that is the same, and that is the opposite. So this is neither. So this is not the opposite. This is not negative f of x, nor is this f of x. This is not the same as the original, nor is it the opposite of the original. So therefore, this is going to be neither. And then the last one, so we have negative x squared minus 2 times negative x minus 2. So this becomes x squared. This is a negative times a negative is a positive 2x, and then this is minus 2. That's the same. That's the opposite. That's the same. So this one is also a neither. They're not neither because, once again, we don't have the exact same answer as f of x, or is this the opposite of f of x? So if you get f of x, then you know it's going to be even, and if it's going to be the opposite of it, then you know it's going to be odd. All right, thanks again for watching. Have a great day.